So in the last lesson, we spoke about solving quadratic equations, and we said all quadratic equations can be written in the standard form ax squared plus bx plus c equals 0. And if they are in that form, we write down what a is, we write down what b is, and we write down what c is, and we plug that into this formula, and then it gives us two answers, or almost always gives us two answers. Give me a thumbs up if you are familiar with that process and method. Give me a thumbs down or unhappy face if you're not familiar with using the quadratic equation. Because I want to practice, but I will increase the difficulty if you're all okay with the basics. Okay. All right, so just to get the cobwebs off, let's start with a multiple choice question. There is question number 1. It is a quadratic equation, and all you need to do is apply the formula. And I want you to do that, and then once you've done it, I want you to make a choice. And while you're doing that, I'm just going to grab some water. Okay, keep those answers coming. Okay, what are our answers? Who's going to pop their answer in the chat first? So we know that A is 4, B is -5, and C is -3, in which case we get X is -5 plus minus B squared. Now we're going to have -5 squared minus 4 times 4 times -3. And that's all going to be over 2 times 4. So really, we get 5 plus minus, and the thing inside the square root bracket is called delta. And it tells us about the nature of the roots. And in this case, del 4 times 4, it's 48 at 73. So is there something that looks like that? I do believe there is, ladies and gentlemen. This 73, okay, but 5, so it's going to be C. The correct option is going to be C. All right, so that was how we apply the quadratic formula. Let's go down to a more difficult one, or slightly more difficult. Can you find me the answer to that quadratic equation? You have a choice. You have the choices A, B, C, and D. I'll write the formula up here for you. Okay. Let's see if we can get our answers here. I want to see those votes. You got to commit if you want to learn something. So please make a commitment. A, B, C, or D is your answer. For me, I see minus minus 6, plus minus, and then, actually, let me zoom in a little bit. Then it's going to be in brackets, minus 6 squared times 4 times A, so that's 4. Then it's 1. And then this is going to be 2 times A, so that's 2 times 4. What is my delta value going to be? What is your delta? What is the value that you get? Sometimes we use the triangle symbol for delta. What is your value that you get inside the root? 36 minus 16, you should be getting 20. That's what I get. Yeah. Okay, so which one is the correct answer now? That is what you need to think about. Well, the one answer will be 6 plus square root 20 over 8, or x will be equal to 6 minus square root 20 over 8. And I'll just do one just to make sure we are 6 plus square root 20. But now that's not enough. I have to divide it by 8. And I get 1.31, which is B. So the correct answer is B. Give me a thumbs up if that went okay for you. Give me a thumbs down or unhappy face if you were struggling with that. Okay, cool. Okay. So let's go on to one where there's a graph involved. Oh my goodness. What is going on with this question? So what we have here, let me make it a bit smaller so it doesn't. If we look at this question, this is quite important because later on we're going to be doing a section on functions. And it turns out quadratic equations and functions are actually very closely connected. So if we talk about this graph, y equals x squared plus 5x minus 6, you can imagine that that graph, whatever it is, would be somewhat connected to that quadratic equation. And how it would be connected is if you want to find the x-intercept of any graph, what do we need to do? What do we always need to do to find the x-intercept of any graph? Who can tell me? Yep, y equals 0 is what you need to do. Okay, so if you imagine making y 0, what you'll notice is that in this particular situation, if you solve this equation, you get the x-intercepts of this graph, which are going to be here and here. So actually, instead of having to work this out using the formula, you can just look at where it cuts the x-axis. So which option do you think is the correct answer now? You don't even have to do it with the formula. You can just do it using knowledge of this idea. Which one do you think fits the picture in front of you? All right, so if we look here, what we notice is that's a 1 and that's a -6. So which option has that? 1 and -6, the option has to be C. And so the correct answer for this would be C. And just to show you, now I'm actually not going to even use the formula. I'm just going to use factorization. But just to show you that I'm telling you the truth, if I factorize this, I would get x plus 6, x minus 1 is 0, and therefore x is -6 or x is 1. And you notice that that is exactly the same as what I've got here. So I want you to just be aware of the connection between the graph, the x-cuts of the graph. This graph is called a parabola, and solving the quadratic equation. Okay, now let's do this one now. I want you to solve this quadratic equation for me and tell me which of the four you think is correct. Now, watch out, because this isn't in standard form, huh? So there might be something that you have to do before you can. All right. Who would like to share what they think needs to be done in order to do this question? What do you think I need to do? What's my first step that I need to do to deal with the structure of this? Who's feeling generous with their knowledge? I think you know the 11 is the problem. Yes, Sange and Rulani, you are spot on. And if I take away 11 from both sides, the standard form of this quadratic equation is going to be this. And so then we know that A is 4, B is 7, and C is -9. And so then at least we're on the right track to find the answer. I'll give you some more time to put your answer in though. So x is -7 plus, and we'll have b squared, so times 4 times -9. And that's all over 2 times 4. So we have -7 plus minus whatever delta is over 8. Now delta is 4, let's have a look. 4 times 4 times 9 plus 49 So delta is not a perfect square, so it's going to have irrational roots. But basically, I have to solve that. And then pop your answer in the chat. I'm going to give the answer away in a moment. I don't want to rob you, though, of the joy of the victory. So lots of students are saying D. We'll find out in a moment if we agree with that. So we have -7 plus square root 193 divided by 8. And we get 0.86, which is part of D, and it's the only one that has that. And so the correct option is D. Okay, perfect. You guys are getting good, so I'm going to start to take up the difficulty level because I can see you're comfortable, and so I'm going to start adding in things like fractions and all that. But before we'll do that in the second half of the lesson, let's just do another one of those graphing ones. So I don't want you to use the quadratic formula. I want you to say, according to the graph, what is the solution to x squared plus 2x minus 3 is 0? And the graph is y equals x squared plus 2x minus 3. And I want you to use the thinking that I showed you last time to help you figure that out. So what we said was to solve this is exactly the same as this. And to find the x-intercept, we just make y naught. So we just made that naught. And then where it cuts the x-axis is at -3 and at 1. And so the answers are going to be x is -3 or x is 1. And the only option for that is A. Perfect. All right, everyone. You have showed me that you understand how to use and apply the quadratic formula. In the second half of today, I'm going to show you the more interesting cases in which quadratic formulas come up. And then we'll go from there. But we need to go and take a break now. So how can I spice it up to keep you guys entertained in this second half? Well, let's just start with this one. I want you to solve this quadratic equation for me, and I'll give you just 2 minutes to do it, but there's something a little different about it, which you'll notice in a moment. So I think we all know. Now, what is a bit different about this one? Can you tell me in the chat what you think is different about this one? What do you spot that's a bit different? So it's not in standard form, absolutely. So we had to change it to standard form. But then I was also interested in terms of what you are getting when you start subbing in values into the quadratic formula. What do you notice about, and maybe you didn't use the quadratic formula, maybe you used factorization, but what did you notice about when you started to calculate your answer? So Muluseni said there are two roots that are the same. They're both 1. So the reason, you're right, the reason that works is that the discriminant or delta is 0. And so what you'll notice is that when you do all your working out, this bit over here becomes 0. And what that means is the plus minus has no effect. Plus or minus 0 does nothing, which means that there's actually only one, or what we say is the nature of the roots is that they are identical. There are two identical rational roots here because delta is a perfect square. It's just 0. So the answer will be x is 2 over 2, which is 1. And it doesn't really matter about the plus minus because the square root of 0 is still 0. And so the answer to this is just x is 1. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't. Okay. Cool. Well, then let's do this one. Now, these all have something a little bit more interesting about them. That's why I'm including them. I know they look simple, and they are simple, but it's important that we cover all the cases. So give that one a go, and then tell me what you observe, or tell me the answer you get. See how it goes. So something is a bit different about this one. What's different about this, solving this quadratic equation? So, ladies and gentlemen, I think something interesting is going on in... Oh, no, wait, I lie. I lie. It's not that interesting. It's a perfect square. Now, why is it so nice when it's a perfect square? Well, we know what the answer is. The answer is going to be minus 3 plus 7 over 2, or x is going to be minus 3 minus 7 over 2. And in which case, we get x is 4 over 2, which is 2, or x is minus 10 over 2, which is minus 5. Now, the interesting thing about the example is that when delta is a perfect square, notice we don't get messy answers. We say that the roots are rational. And also, when delta is greater than 0, the roots are unequal. And the reason they're unequal is that the plus and minus make them unequal. So just something to spot. Whenever you see what delta is, you kind of know something already about what the final answers are going to be like, because delta kind of tells you ahead of time about some of the characteristics. You didn't have to use the quadratic formula, no, Siamtanda. I'm just using the quadratic formula today for everything. But you're right. In some ways, it's quicker to use the normal thing there. Okay, let's do this one. Sorry, that was looking for a good one, but that was still useful. But let's try and do this one. This is the one I was thinking of. Okay. No, actually, you know what? I think I'm gonna. There's two ways you can do this. Some of you would probably do this, and that's completely fine. And some of you will probably do this. Both of those are fine. I'll give you the same answer. I'm going to go with the blue one because it's just got positive values, but both are fine. So I want you to tell me in the chat, what do you spot about these ones when solving them? Is there anything interesting about this one? Who feels like they know something about this one? Okay, so I don't think delta is 7. Let's have a look. But you're right, it's always good. Let's have a look at delta. So I think delta is 9 minus 40. So I get delta is minus 31. Does anybody else get delta is minus 31 for this quadratic? And what does that mean about my solutions? Okay, if delta is less than 0, then we say the roots are non-real and there are no solutions. So we would say here that x is non-real, therefore no solutions. And this will happen whenever delta is less than 0 because you cannot square root a negative number. In your calculator, if you do that, it just says error. And so that's why I wanted to show you that scenario. It just literally means there are no solutions. In terms of the graphical picture that we had earlier, if you imagine that this graph is a happy parabola, what it means if there's non-real roots is that the graph never cuts the x-axis. That's why the roots are non-real. Okay, give me a thumbs up if you're okay with that. Give me a thumbs down if I lost you in that one. I basically just wanted to show you one where delta was negative. Okay. Well then, let's turn up the heat a little bit more. Oh, here's a question, Stephen. Yeah. So while I'm going to get everyone going, and then I'm going to talk to Stephen about his question, and I think that's a good way to do it. So Stephen, can you hear me?
Yes, I
Cool.
can
Yeah.
hear you.
Yeah.
So I'm a bit, not say confused, but I just want to confirm with you, sir. When I tried putting it on the
Yeah.
calculator, the way you had it, so it gave me a proper answer. I don't know what happened because it gave me 4,283 and then continues it as a decimal. I don't know if that's something to look out for
Okay.
or
Stephen, so I think the problem would have come is that you didn't get your delta value right. You left out a negative or something. Because the only way your calculator, like if you put in your calculator now square root minus 31, what does it say to you? So do
give
you get,
me 0.31.
so no, but put minus 31 and then a square root bracket and see what you get.
Oh, it gives me no solution.
Okay, can you see that? So you made a mistake in your inputting into the calculator. So just be careful there and just check that you are, the order, the brackets and all that stuff. Okay.
Thank you, sir.
Cool. Thanks for the question, Stephen. That was helpful. All right, everyone, we are doing this one over here. We are solving this quadratic equation. And when in doubt, use the formula, I guess. Is that another question? Oh, no, I think Stephen's question has been answered. Okay. So even though there's a fraction here, I don't actually have to do too much hard work. I just need to bring the 3 across, and then make sure I've got my A, B, and C values. So I'm going to give you a bit more time, but when you've got the answer, I want you to pop it in the chat. So minus a quarter, plus minus over 2 times A, so 2 times 5, which is going to be a quarter plus minus whatever delta is over 10. And I just need to make sure that I get the right delta value. So I get that plus so what I get is I get 0.775. Did you guys get 0.775 for the one? Let's have a look. I'll check myself. Well, let me put the answer back in. Let me get delta first. So for delta, 4 times 5 times 3, so 60, and then I get, that's 1 over 16. So I get 60 and 1/16 inside of delta. So that is what my delta is. And then I've left something out. Sorry, I made a mistake because I forgot about the quarter in front. So quarter plus square root of 60 and 1 over 16. And then I get 8. And then 8 divided by 10, I get 0.8. So I was having a moment. X is indeed 0.8 for the one answer. Or X is going to be minus 0.75. Give me a thumbs up if you got that. That was me. So what I did, everyone, just so you know what I did, is I was doing it without looking at the board, and I just said this bit over here divided by 10. And I left out this quarter in front because I wasn't looking at that. So watch out for that. So what if you got an LCD, then use the quadratic formula? Rulani, you'd get the same answer. You would multiply through by 4, and so you'd get 20x squared minus x equals 12, and then you would have to solve that equation, 20x squared minus x minus 12 equals 0, but you get the same answer. And can you leave it as fractions instead of decimals? Absolutely. It just depends on what your teacher is, what the exam says. All right, I want to do 2 more, but things are going well. So here is another one. I want you to solve this. Now, we need to work as a team here. What do we need to do before we can solve this? In fact, how do we even know it's a quadratic? And then what do we need to do? Yeah. So Rulani, you got exactly the same answer as us. It's just in common fractions, not decimals. But that's equivalent answer. So you're completely perfect. Okay, let's do this one. Maybe this will be our last one for today if it takes a while. Otherwise, maybe we'll squeeze in one more. See if you can solve this quadratic. What do you think I need to do first? Actually, this is our last one. We're going to make this our last one. We're not going to go further. This is a nice one, a nice tough one to end on. You have to simplify the equation. Well, I think we also need to, so I'm going to leave the 7, and I'm actually going to FOIL all that stuff. So I multiply that out, And then I'm going to get, so I'll give you that hint to get you going. You need to almost like unfactorize this bit. And then once you've done that, I think the 7 probably needs to be multiplied out as well. So we'll get 7x squared minus 7x minus 42 equals 6x minus 2. And now I feel like standard form is our next step, and then solving the equation. So I'll wait a bit for the answers to come flooding through. Just want to check, is that a hand up, Simtanda, or is that just up from earlier? Okay, so 7x squared. Then this is minus 13x. And then this would be minus 40 equals 0. So that would be my standard form, but I still need to do the working out. Do you have a question? Oh, let me unmute you, Simtanda. Sorry, I could have unmuted you much earlier. Thank you for being so patient. How can I help?
So it's regarding the last question.
Say that again.
It's regarding the last question.
Oh, the last question. Okay, let me zoom out while everyone is working on that. Can you see okay?
Yes. So basically, you see once you get to the after the quadratic formula, like 1/4.
Yeah,
plus
this
minus
bit.
square. Yes. So basically, don't we change it into improper fraction? The one side
Yes.
is square root.
Yeah, no, that's a good idea. Yeah. So you did.
Then you find the square roots of each the numerator and denominator.
Yeah. But a lot of this would be done. You wouldn't want to do too much working, hey? So you want to get your delta value, and then but actually you're right. Improper would probably, although, it's because it's 60 times 16, so it's quite a big value. What number do you get? Actually, it's not too bad. You use 961.
Yes. Over 16.
So you got 961 over 16. Okay, so you basically would then go, and then you had this 10. So you basically go 1/4 plus the square root of that over 10, and then you get your answer. And then 1/4 minus the square root of that divided by 10, and you get your answer.
I'm asking if it's possible to like the what you call the values in the fraction. Don't we like square root for each one? Because
It's possible. Yeah, and then what would happen is you would say the roots are rational. So if these were perfect squares, it is possible to have something in there which is like 25 over 16 or something. That does happen, yeah. Yeah.
Okay, thank you, sir. That's
Pleasure.
what I had to ask.
No, it was a good question. You asked good questions. Okay, so let's wrap this up. So minus 13, and then plus minus, then it'll be minus 13 squared minus 4 times 7 times minus 40. Let's keep that over there. And then this is 2 times a, so 2 times 7. So x is 13 plus minus whatever I get for delta over 14. Let's see what I get for delta. Apologies, it's a bit untidy, but... And then minus 4 times 7 times... Do you get delta as 1, 2, 8, 9? Oh, sorry. Do you get delta as 1, 2, 8, 9, everyone? So I'll try that again. So 4 times 7 times 40 plus 169, 1289. Yes. So what's going to happen? Some of you, this is going to become positive 169. right? That's going to become positive. So if you got that wrong, you may not get the correct answer of 1289. So I want you to put that back in your calculator. Let's just see if you have any disagreements. Minus 4 times A. What was A? A is 7 and C was 40. So we're happy that A is 7, B is minus 13, and C is minus 40. 4AC. So I'm pretty confident of my answer. I don't know if anybody else has a different variation, but B squared is 169, right? So I know I've got 13. I know this is 169, and then I know this bit here is going to be plus, because there's a negative times a negative, so we go 4 times 7 times 40. That's 1120, and then this is over 14. So that is correct. Okay, so for those who made a mistake there, you know where you went wrong? Is it clear? So I think the two negatives here make a positive. And so then my final answer is going to be 13. Now, what's the square root of 1289? So 13 plus the square root of 1289 over 14. Or x is going to be 13 minus the square root of 1289 over 14. So let's see what I get. 13 plus square root 1289. And then I divide by 14. And I get 3.49. Or I get, let's see what my other one is. 13 minus square root 1289 divided by 14, and I get x is minus 1.64 when I round up. I'll just check my first answer just in case. 1289 divided by 14. Yes, I believe those are my final answers. Give me a thumbs up if you're with me. Give me a thumbs down if you're doing something different.